Hi children, welcome back to my YouTube channel. This is the second video of the topic straight lines. To watch more educational videos, please subscribe my channel and click on the bell icon. In this video, we are going to discuss about parallel lines and perpendicular lines. What are the properties where we can understand if two lines are parallel to each other? If two lines are parallel to each other, we know that their gradients must be similar. For example, if you get two lines, L1 is y equals to m1x plus c1 and L2 where y equals to m2x plus c2, you can simply understand their gradients are similar, therefore you can write m1 is equals to m2. In this example, we have 5 lines. Out of the 5 lines, we have to select the lines which are parallel to each other. If you consider the first line, y equals to 2x plus 3, the other gradient is 2. The second line is y equals to 3x minus 2, the other gradient is 3. Third line, y equals to 2x minus 5, the other gradient is 2. Third line, y equals to 0.5x minus 5, the other gradient is half or 0.5. Third line is y equals to minus 3x plus y, the other gradient is minus 3. Why did I specify about the gradient? Because we can discuss about the parallel property using their gradient. So if you refer to these equations, you can understand that the lines y equals to 2x plus 3 and y equals to 2x minus 5 both are having the same gradient too. Therefore, those two lines are the only lines which are parallel to each other. When you are working out this question, from my experience, some of the students misunderstand that y equals to 3x minus 2 and y equals to minus 3x plus 5 are parallel to each other. But you have to understand that to be two lines are parallel to each other, the gradients must be similar, not the modulus. The gradient must be similar. So the first line is y equals to 3x and other one is minus 3x. Therefore, they are not parallel to each other. In this example, it has mentioned the line L1 is parallel to y equals to 3x minus 5 and passes through 1, 10. Find the equation of the line L1. What are the properties where we can understand? They have mentioned line L1 is parallel to the line y equals to 3x minus 5. If the two lines are parallel to each other, we can simply understand that their gradients must be similar. We know that gradient of the line y equals to 3x minus 5 is 3. Therefore, the gradient of line L1 must be 3. Then we can write the equation of line L1 as y equals to 3x plus c. But still we have a doubt how to find the value for c. They have given another information that line passes through 110. That means when x coordinate is 1 in the equation y equals to 3x plus c, the y coordinate must be 10. Therefore, I will substitute 1, 10 in the equation y equals to 3x plus c to find the value for c. If you substitute, you get the answer 10 equals to 3 times of 1 plus c, that is c equals to 7. Therefore, simply you can write the equation of line L1 as y equals to 3x plus 7. In this example, it is stated that the line L1 is parallel to the equation y equals to 1 over 3x minus 5 and passes to 6 minus 4. We need to find the equation of line L1. Since line L1 is parallel to y equals to 1 over 3x minus 5, the gradients must be similar. Therefore, you can simply say the gradient of line L1 is 1 over 3. Therefore, I will write the equation of line L1 as y equals to 1 over 3x plus c. Then, our doubt is to find the value for c. As the same way what we did in the previous question, we can understand that line L1 passes through the coordinate 6 minus 4. That means when x coordinate is 6, y coordinate must be minus 4. Therefore, you can write minus 4 equals to 1 over 3 times of 6 plus c. With that you get the answer c equals to minus 6. Then we can write the equation of line L1 as y equals to 1 over 3x minus 6. The second property we are going to discuss in this video, that is perpendicular lines, or sometimes they mention as normal lines. If the two lines are perpendicular to each other, simply we can write their products of their gradient should be minus 1. So if you get two lines, y equals to m1 x plus c1 and y equals to m2 x plus c2, if the two lines are perpendicular to each other, we can simply say m1 into m2 is equals to minus 1. That is the property to understand about perpendicular lines. If you refer to example 4, if we consider two lines y equals to 3x plus 4 and y equals to minus 1 over 3x minus 5. If you get the products of their gradient, the gradient of the first line is 3 and gradient of the second line is minus 1 over 3. If you multiply, you will obtain minus 1. Since the product of the gradient is minus 1, you can simply say these two lines are perpendicular to each other. If you come up with example 5, the two lines are y equals to 3x plus 4 and y equals to 1 over 3x minus 8. If you multiply these two, the gradients, 3 multiplied by 1 over 3, it's 1. This is 1, but remember that this is not minus 1. If it is not minus 1, we cannot say those two lines are perpendicular to each other. The example 6. The two lines are y equals to 2x plus 4 and y equals to 1 over 3x minus 8. If you multiply the gradients, 2 should be multiplied with 1 over 3, it's 2 over 3. Since the product is not minus 1, we cannot say these two lines are perpendicular to each other. Let's try to work out with the example 7. It mentions a line L1 is normal to another line y equals to minus 3x minus 5 and passes through the coordinate 6, minus 4. They ask us to find the equation of line L1. We know that line L1 is perpendicular to the line y equals to minus 3x minus 5. If the two lines are perpendicular to each other, we can simply say the products of their gradients must be minus 1. Then I will consider the gradient of line L1 is ML. And we know the gradient of line y equals to minus 3x minus 5 is minus 3. If you multiply ML by minus 3, you should get the answer minus 1 from the previous theory. With that, you can get the answer for ML, the gradient of line L, as 1 over 3. Therefore, I will write the equation of line L1 as y equals to 1 over 3x plus c. Now our doubt is how to find the value for c. To find the value of c, they have given another information. That means the line passes through 6 minus 4. That means the line y equals to 1 over 3x plus c satisfy the condition x equals to 6 where y equals to minus 4. Therefore, I can replace 6 instead of x and minus 4 instead of y in the equation y equals to 1 over 3x plus c. When we replace these figures, you will obtain minus 4 equals to 1 over 3 6 plus c. With that you will obtain the answer c equals to minus 6. Therefore, we can write the equation of the straight line y equals to 1 over 3x minus 6. This is called y equals to mx plus c format. Then I will multiply this entire equation by the denominator of the gradient. 1 over 3 means 3. If you multiply everything with 3, you will obtain the answer 3y equals to x minus 18. Then I will take all the terms to one side. There it turns into 3y minus x plus 18 equals to 0. This is called ax plus by plus c equals to 0 format. Hopefully you understood the concepts in this theory. I have added a few more examples for you to try at the end of this video. Please go through them, and if you have any doubt, please comment on the comment section.